we see the night sky as a vast array of thousands of luminous objects that appear as tiny dots. Among them, there are several nebulous patches called galaxies. How far away are these galaxies? Are these objects scattered among the stars just as small as they appear to the naked eye? Or are they larger? How far away from us are they? And how can we tell? The answers to these questions came with a crucial discovery, but it was not made by a great professor or famous scientist, but by a modest, hard-working astronomer, the remarkable Miss Henrietta Leavitt.
I was working at Harvard College Observatory as one of many computers, working for minimum wage and sorting through piles of data of thousands upon thousands of stars. For centuries, sailors from the southern hemisphere spoke of two fuzzy patches in the sky that looked like detached parts of the Milky Way. These became known as the Small and Large Magellanic Clouds. They could not be seen from the northern hemisphere, but we had many good photographs of the clouds taken from our observatory in Peru. I spent many years measuring and studying the stars in the Small Magellanic Cloud. I soon discovered that the brightness of many of these stars changed periodically. When a star was brighter, its image on the photographic plate looked bigger. When it faded, it looked smaller. These are called variables. Day after day, month after month, year after year, I searched for those variables, measuring their brightness and computing their periods. And then, a pattern started to emerge. I noticed a remarkable relation between the brightness of some of these variables and their periods. The brighter the variables had longer periods. The fainter variables had shorter ones. The relationship was unmistakable. I was able to do precise measurements for 53 such stars. Then I made a graph. On one axis, I plotted the length of their periods, and on the other, their maximum brightness. A precise mathematical fit emerged, showing what became known as the Period-Luminosity Relation, the laws obeyed by these stars. These stars became known as Cepheid Variables, or Cepheids for short, as we first found them in the constellation Cepheids. Relationships like this don't happen by accident. Rather, they must reflect something deep about the true nature of these stars. I hoped that systematic studies of these variables would shed more light on this issue, but I had no time for that. Others would have to take up that task.
Indeed, they did. Henrietta might have continued her work had she not been held back by her poor health. She died several years later after battling a long illness. But the results of her labor lived on. Astronomers quickly realized the importance of Henrietta's discovery. Cepheid variables are easy to spot, and they have been found all over the sky. Einar Hertzsprung realized that they can be used as light beacons to measure distances. By comparing Henrietta's stars to Cepheids that are nearby, Hertzsprung was able to estimate the distance to the Small Magellanic Cloud. Harlow Shapley used Henrietta's Period-Luminosity Relation to estimate the size of our galaxy. And Edwin Hubble used this relation to measure how far away other galaxies are from us. He found that the universe is expanding. Wendy Friedman led a team of astronomers that found out just how quickly it is expanding. Using Henrietta's period-luminosity law, They were able to measure the distances to galaxies that are 66 million light-years away. Henrietta's discovery became one of the foundations of modern cosmology.
Miss Leavitt had the happy faculty of appreciating all that was worthy and lovable in others, and was possessed of a nature so full of sunshine that, to her, all of life became beautiful and full of meaning.